Welcome to Moody Coda. I'm Mike Moody. I've been working as a professional ServiceNow developer for over 8 years. I started off at a managed service provider, and today I am the lead architect and senior developer at eBay. This is a channel where I like to share my tips and tricks and secrets of the trade that I've picked up over years of experience and what have you. Now, today I'd like to extend on the topic that I've been sharing with over the past few videos regarding asynchronous API calls and what have you. But more specifically, I wanted to share a technique that I learned on how to communicate back to the end user once an asynchronous call or asynchronous job has completed. It's nice to be able to say to a user, hey, guess what? Your job is now done, or your API response has now been returned and processed, and everything went well, or maybe there's an error. And so bring that to the user's attention with an alert, a pop-up in the UI on demand when that job has fully completed. So the technique that I use to pull this off is actually using a protocol that is built into HTML5 called server sent, and this is a unidirectional protocol that goes from server to client side. Now I just want to go ahead and do a quick demo of what this looks like, and then I'll go through how you can go about setting this up on your own and the code that's involved in all this. There is quite a bit of code, but essentially what we have, what I've done in the system, that I created this custom table to track transaction subscriptions, so you can have the system automatically create a transaction subscription when either you're making an outbound API call that's asynchronous and you know eventually it's going to come back, and then when it does come back you want to put a message on the screen, or maybe you're doing a file import through a data source and stuff, and you're automatically kicking off the processing of that. And once that processing is done, because maybe you're doing it through the service catalog. I don't know if you've ever done that before, but I've definitely done this where, I had a service catalog item. You can attach a file to it, you can submit that, and then it'll kick off a workflow that will copy the file to the data source, run a transform, and then once it's done, it'd be nice to let the user know this is completed with a pop-up. And so you can use that in that context as well. So I have this table that I created to track these transaction subscriptions, and I have this API call that I set up from my last couple of videos. So I'm just going to go ahead and kick off this API call here and show you what this looks like. Okay, so API call triggered. Let me refresh this table here. You can see it actually created a transaction subscription, and now it's processing this call in the background. When the callback comes in, it's got about 20 seconds worth of processing, and then when it's done, we should see some sort of indication on the screen that it completed either successfully or failed. We shall see. Should be momentarily popping. There we go. Hey, look at that. We got a successful async response with a result, which has some data that we received from the remote system emulator. So this is what I'm talking about. So that's nice. You can just go about your business doing whatever in the instance, and then get your pop-up whenever, to let you know that, hey, the job is finally finished. So, maybe it's not something you want to annoy your users with when things are successful, but perhaps, when there's an error or something failed in that transaction, you might want to bring that to their attention so they can go back and maybe retry that again, right? So then I'll go ahead and close that out and refresh. This transaction subscription is now gone because, the message has already popped up, and I closed it out and it cleared it out. All right, so let me show you how you can go about getting all this set up and what it takes to do something like this. All right, so what I'll do is jump into the studio environment here, and I'll show you the various pieces of code that I put in place to pull this off. The first thing I did is I created that transaction subscription table in a custom application scope I call UI notify. So this transaction subscription table has an event name field, has a record key, has a table field and a transaction ID, and importantly, it has a user field, which is a reference field, which is on the next page. So here we go. So this is a user field, it's reference to the sysuser table. Okay. So the idea of this table again is to track, a subscription for a given user. So I'm user A, and I want to subscribe to event B, and then and then the record key and the table tracks, the source glide record from which you are associating this event to, right? All right, so this table was set up first in place, and then the second thing I set up was I created an event registration, and this is a custom event that I decided to create to pass that message once my async call has completed. So this is indeed called async call complete, and it's fired by the async callback function. Now, I will show that implementation nearer to the end, but just to know, I set these two things up. And then the third thing I did is I set up the script include is a UI notify utility script include set up here. Now in this script include, I have two functions. There's create transaction subscription, and there's a trigger notify event. So the create transaction subscription essentially goes and will take five parameters as input, which specifies the event name that you're subscribing to, the source table you're coming from, the source record you're coming from, the optional transaction ID if you want to provide one, and then the executing user who is subscribing to this event. So it takes all that information and it basically will just insert a record into that table here by populating all the respective fields, only if it doesn't already exist, right? So that's what that function does. And then the second function, trigger notify event, takes two parameters. These parameters are parameters that are available in my callback function because this function is explicitly written to trigger an event that is a response to an asynchronous API call. So in that callback function, I am triggering this function and passing along the param object, a custom JSON object, which has any number of dynamic parameters in it. The key of which I'm using later is a current glide record object that I'm passing along with this async call complete. And then also the response object. The response object is a custom object that contains information on the API response. So it'll have the HTTP status code in there along with the response body that can be parsed out into a JSON object. So I am taking that, I'm checking the status code. If it's successful, then I'm constructing a message indicating it's a successful response and I'm including the data. If it's unsuccessful, I'm constructing a message indicating it's a failed response and including the status code. And then I'm calling the event, that custom async call complete event, passing in a glide record and the custom message along into that event, okay? And that's all that this script include is doing. And then the next thing I did is I set up a business rule against the ECCQ table to register the subscription. This is responsible for creating a subscription whenever an outbound ECCQ REST probe record is generated. So this is the moment in time in which I'm creating that subscription. So the minute the system sees inserted into the ECCQ, before insert, a REST probe type of ECCQ entry, which is an API outbound API call through the mid server, with the queue set to output, then it will trigger this script here. All of which does is new up an instance to that UI notify util we're just looking at, and then executes that create transaction subscription function, passing in the appropriate parameters to subscribe to this event and subscribe as the currently logged in user. Okay, so whoever is responsible for triggering that insertion into the ECCQ table is the person who's going to be subscribing to the async callback complete event. All right, so that's that business rule that was put in place. And then the next thing I did is I set up a server sent Ajax script include. So the purpose of this is client callable. It's designed to be used as an Ajax call in Ajax calls back to the server. So this particular script has two functions in it. One is to get the transaction subscriptions from that transaction subscription table, and the other is to delete a specific transaction subscription from the same table. So with the get transaction subscriptions, what we do is we get the URL and location parameters that are passed in through the Ajax call via sysparm underscore URL and sysparm underscore location. I have a custom object that I'm constructing here, which is going to consist of a URL and an array of subscriptions, okay? So we're going down through here, and then what we're going to do is we're going to query that transaction subscription table for all subscriptions that are associated to the current user, or the current user sysid right here, which is being grabbed from the current user. All right. So it's going to get all the subscriptions for that user, and it's going to push those into a subscriptions array, and it's going to push in custom JSON object that consists of the event name that you're subscribed to, as well as the record sysid that we're subscribed to. And then once I get all those subscriptions, I put that into the custom result object, and then I return that custom result object in the Ajax call, all right, to the client side. And then the second function in here deletes a transaction subscription, and here we retrieve the sysid of the record that we want to unsubscribe from, or delete, I should say, and then also grab the current user ID, and then we go ahead and query the transaction subscription table with the current user ID and the record ID, and then we go ahead and delete that from the table, okay? And this is called from client side as well. The idea being that once on the client side a message is displayed and we close that message out, on closure of that message, we want to delete that transaction subscription record from the transaction subscription table, right? Okay, so then well, not the last thing, but the next thing you have to set up is a server sent processor on the server side. Now this is a part of the meat, I should say, of this implementation, and the potatoes would be the client side. So this is the server side of the connection for the server sent connection itself, all right? So what I did is I set up a processor here of type script, made it active. I disabled the CSRF protect to not have to deal with authentication in this particular use case. And then I set the path to server sent, and it gets automatically prefixed with the application scope name, all right? So that being said, what's happening in here is we're extracting from the URL that, so when the client side calls to this endpoint, it's passing along in the URL a couple of parameters. And those parameters are event subscription and the record sysid, okay? So extracting those two parameters from the URL here, I'm setting up the headers for the server sent responses, and it needs to be set up in this manner. We need to specify a content type of text event-stream that is explicitly used for the server sent protocol. We need to set some additional headers, disable cache, right? We don't want to cache the data. We want it to be live and not stale or retained. And then the connection, we need to do a keep alive on the connection itself. And then finally, opening up the access for cross control, for cross origin access here by doing a wildcard. And this allows the connection from the browser back to the server. Okay, and then at the end here, I simply trigger this function here called event fired, passing in those two URL parameters that I had parsed out. Inside of this function is constructing an encoded query that is querying the sys event table based on the event name that was parsed from the URL, as well as the instance or glide record sysid that was also parsed from the URL. In addition to that, I'm grabbing any events that match those two values, in addition that were created within the current minute or the last minute. Since it's a live connection, it should be frequently querying, and this should cover all bases there and grab all those events. So it does that query, and it does a loop across all events that it finds created within the current and last minute. And then once it has those events, it news up an instance of the glide record associated with that event in order to be able to use that in the message. And then I construct an HTML formatted message that I want to display on the client side. Okay, so I'm wrapping it with some HTML here. The message I'm just passing along from the event parameter one here. So, you know, the event that I've got here in the sys event table, what I'm doing here is I'm making the assumption that the first parameter of that event is going to contain the textual message that I want to display to the end user in that pop-up. And then I'm wrapping that in some a header, and then on top of that, I'm constructing a custom JSON object for passing in the data that I want to pass in to the client side as well. So this, I'm putting the message output, which is this nicely formatted HTML message. I'm adding that here. I'm adding the ID, which is the event sys ID. I'm adding the instance, which is the event instance, to this object. And then finally, this is the key part here where we write the output to a text event stream, and we construct it because this is text format, and it expects these specific prefixes, the ID colon, and then it's expecting a new line break here, and then data colon, and then the data that you want, and then another or a double new line break here. This is the format that the server-sent protocol is expecting, that you separate the ID from the data with a new line character here, since it is text. Now the data, I went ahead and encapsulated that as a JSON string, which is a representative of this output object that I built up here, which has our message included inside of it. Okay, so this is writing the output to the stream for the connection that's established from the client side. All right, so that takes care of all the back-end server-side setup for this implementation. And now the final bit of code that needs to be put in is we need to create a UI script which handles the client side responsibilities for displaying that pop-up message. Now, the UI script has to be defined, or at least in my use case, I wanted to define it is as a globally scoped UI script, so that it can be marked as global and basically be rendered on any page I navigate to within the platform. Okay, so this is that UI script here. Now in this guy, is, like I said, is marked as global in the global application scope. And so there's a lot of things going on in here, but I'll break it down. Basically, checking to make sure jQuery is available, waiting for the document to load. Once the document loads, I'm creating a class called server-sent-UI, and then on near the end here, I'm instantiating an instance of that class and setting that to this variable UI message util, which should be available on each page that you open in your browser in the platform. Okay, so that UI message util variable. So now this particular class here is implemented this way. So we have an initialize function, which the first thing it does is it makes sure that your browser can indeed support the server-sent protocol. All modern browsers today will support this protocol, at least on the desktop and what have you. You know, Android phone browsers, things like that. The mobile browsers won't support this protocol necessarily, but most major browsers for your PC or Mac today will indeed support the server-sent protocol. Now, the server-sent protocol is implemented within this event source object in the window element, DOM element. Okay, so it's checking to make sure that you have that protocol. Once it confirms that you do, then it sets up some properties on this object. It sets an instance URL to that of your instance that you're currently on. It sets the server sent URL, SS URL, to that instance URL, and it tacks on, concatenates that server sent endpoint for the processor that we were looking at. So that's the prefix of the application scope, and then server sent.do. Okay, and then so it sets that as your server sent URL, and then it sets up the sources. These are the event sources. So it calls an internal function called instantiate event sources. So if we take a peek at that function, instantiate event sources, what we're doing here is this is where we're leveraging that server-sent Ajax script include that we set up on the server side to call the get transaction subscriptions function. So this is going to do that call to the server side. It's going to execute that function. It's going to return an array of transaction subscriptions along with a URL. So down here in this callback function, to that, we're just getting that data back. We're parsing it out. And then what we're doing is we're iterating over all the subscriptions that were returned. And for each of those, we are, constructing an event URL. So that's going to take our base URL that was returned, and then we're going to tack on those parameters that we were parsing out in our processor. So that's the event subscription parameter, and then we're going to set the value to the event name that was returned in the current iteration of the subscription. Then we're going to also set the record sysID parameter, and we're going to parse that out again out of the current iteration of the subscription that we're looking at. And we're going to set that as our event URL. Now, once we have that event URL constructed, then we're going to go ahead and try to push in a new instantiation of the server-side event source object on the client side, passing in that specific event URL. So that will instantiate that connection there. So for that. All right. And then if there's any errors, we're going to just log that out to the console. And then at this point, after going over the entire loop of sources, then we're going to say we're done, right? And then finally, after that, we want to take our current variable, which is the UI message util, which is that global instance of the server-sent UI, and we're going to set the sources to that sources array that we just constructed, which consists of those event source objects that we instantiated. And then we're going to also set up an empty array for tracking the event IDs that we process as we process them, so that we don't accidentally reprocess or throw the same message up multiple times. We need to track that we had already taken care of that one. And then finally, we're going to call this register event handlers function here. This is what sets up the client side to respond to the events that are coming back from the processor from the server side when it sends those events. So let's take a look into that function next. All right, so register event handlers. All right, so there's a lot of code in here, and a lot of this is DOM manipulation, so I'm not going to go in too deep into an explanation of what each thing is done. You're welcome to download this or check it out in the GitHub repository. That'll be in this video, so you can look closer at the details of this, but I'll just sort of cover the highlights here. So once this is called, essentially what we're doing is setting up 3 event listeners, one for the message, for the reception of the message, one for opening the connection, and one in case there's an error with the connection. And right now I'm not really handling the opening or error at this point. I mean, we could log that information out. We could, if an error is encountered or what have you, that would be useful to log out probably. But the main thing that we care about is the message event listener, which is doing the heavy lifting, parsing, and displaying the message on screen. Okay, so if we expand that down, we're getting the data out of the event. We're using that data in order to extract the message from that data, which is our HTML formatted message that we want to display on the screen. And then this is where I'm doing some DOM manipulation, basically getting the body of the iframe that we're looking at here and creating a new element in there. And then I'm setting up that element with an ID. I'm putting some buttons on there to handle the closing of that pop-up window. And once closed, it does some cleanup, like deleting the transaction subscription, which was the function we set up in the server-side Ajax server-side script include there. And then, just doing some more cleanup work here before closing it out, and also displaying the message. And then eventually, so it sets up all that HTML for the message itself. it sets it to the new element as the inner HTML, and then it inserts that element right as the first element in the body, and then also tracks that we just processed that specific event ID so it doesn't happen again the next time around, which, by the way, is on line 28 here. It checks to see if we've already processed the event ID. If we did, it does nothing. Otherwise, it does all this that I was just talking about. And that's basically it. That's the gist of it right there. And yeah, so yeah, again, you can look at this in more detail if you need to from the GitHub repository. So all that is set up to handle the rendering of and closure of that pop-up message on the client side. Okay, so the last final bit is, with all this set up and all this in place, you just need to trigger it. What I mean is, you gotta trigger the event itself to cause that pop-up to show. So we've set up, a business rule to create for us a transaction subscription, so that whenever the target event is triggered in the sys event table, that message pops up. But now we need to actually trigger that target event in the sys event table. And in our use case, we're doing it for an asynchronous response, API response. And so I had set that up in a previous video in my sharing application here. I have an integration utility, which is making an outbound GET call. And then the response is coming back in on the ECCQ table because it's using the mid server, which has a business rule that's triggering this callback function here, passing in parameter object as well as the response object. And so what I've done here is I've modified this function to, on line 40, to instantiate a object of the UI notify utility, and then trigger notification event. So I'm triggering that notification event function. I'm passing in the parameter object, and I'm also passing in the response object as parameters to that function. So this one I talked about and covered earlier, the trigger notify event, but I'll just briefly hit it again. So that would be in this util, and trigger notify event is right here. So it's expecting the parameter object and the response object. And so again, this is where we actually fire that async call complete event. There we go. And we pass along the glide record object for the outbound ECCQ record. Yeah, so that's basically how you implement this. That's the sum up of this. So there's a lot of moving pieces to this, but it's really cool, really powerful technology. It's very efficient and performant, because it's not like a polling mechanism that's constantly hitting the instance. It's a live connection that's established, and whenever the server side wants to send a message to the client side, it can do so via that processor and that established streaming connection that they have to each other. So it's very efficient and performant. You can use this technology to feed for a lot of different things. A couple of the things I've used it for, one is this scenario that I just went through for asynchronous response handling, and I've used it for import set processing for transform maps and what have you, when that's completed, to throw messages on the screen. And I've also used it actually as a way of populating a live dashboard of alerts and events on the client side. And so this technology is capable of handling like hundreds of transactions and messages per second. And yeah, it's pretty freaking fast and performant, and lends itself to some advanced use case scenarios. Anyways, there you have it. One more demo of this behavior. So I'll go ahead and just trigger another API call here. And let me see. We'll look for transaction subscriptions. We'll just check out this table. You can see that subscriptions there again. And then, it's doing its thing. It's taking its time, running its process there. It's a little slow running process in the background. I'm working on whatever, doing my business, and oh, there, I'm notified. It's done. It was successful. Nice. Okay, Good to know. Okay, I can close that out and go about my business, you know. Anyways, there you have it. I hope you enjoyed it. I hope you find that it's useful. You can check out the code in the GitHub repository in the video link below. Thank you for watching, and hope to see you next time. All right, take care.